Okay, this is our next to the last standard in weather that we're studying. It says, explain the influence of convection, global winds, and the jet stream on weather and climatic conditions. Now, first of all, we need to know that thermal energy carried by the ocean currents has a strong influence on the climates around the world. Remember, the ocean was the great moderator that we studied early in the year. Areas close to oceans have more moderate temperatures than areas inland. Now, those areas near the ocean, because the water temperature can't change as quickly as air temperature can, it just tends to keep things kind of in a smaller band of, or smaller zone that the temperature actually changes. When you get further away from the ocean, the weather temperatures can vary a whole lot more. Now, changes in weather involve air movements, formation of clouds and precipitation. The energy for all of that to take place comes from, yep, this is about the third time I've said it, from the sun. I bet that that's going to be on that test. Energy comes from the sun to make all the weather changes happen. That's what it says. Now, convection is a very important thing in moving the heat through the atmosphere and the oceans. Convection actually transfers heat from one place to another. Winds result from uneven heating or convection of the atmosphere, and the speed of the wind depends on the difference between the air mass and temperatures. We call that the pressure gradient. And actually what happens is if you have a very warm front and a very cold front and they meet, then you have a lot faster winds, and if they're just a little bit different, then the winds are just much milder. But it has to do everything to do with that pressure gradient. Now, you've heard of the jet stream before. It's actually a fairly narrow zone of winds in the upper troposphere. It's most common, it got erased, in the middle latitudes and generally come from the west to the east. Now, the Coriolis effect we've talked about is caused by the Earth's rotation on its axis. Above the equator, wind tends to go to the right, and below the equator or south of the equator, it tends to go to the left. It's the Coriolis effect that is responsible for large cyclones. And then finally, the last thing in this standard is they want you to know about the Gulf Stream, and I'm sure they want us to know about that because it affects North Carolina. But the Gulf Stream is a very powerful ocean current. It reaches the North Carolina coast, and when cold ocean currents meet warm ocean currents, weather systems intensify. That's why we really need to be concerned sometimes about hurricanes on the coast or bigger storms on the coast. They're much more intensified when you have you have warm water and cold water coming together, no different than when you have a thunderboom or kind of a storm going on. You've got really warm air and really cold air meeting each other. You have all that energy and it transfers. Same kind of things happen in the water, and that affects all the weather. One more standard to go after this. I bet you're as ready as I am.